Middle of the Day Deployments with Eric Fleming.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Hello, welcome back. I am Jeffrey Palermo, your host. And remember to go to www.azuredevops.show. You can see past show notes and check out all the links and other episodes. Also, one thing that you'll want to check out is my new book. And I know I've announced it on the past shows a few times, but you can go to aka.ms/.NET DevOps book. And you can also go to bit.ly/.NET DevOps project for a public Azure DevOps Services project. That's the example of the book. We have a special offer if you want to reach out to me on Twitter at Jeffrey Palermo. That's JEFFREYPALERMO. And if you are running a user group or speaking at a user group or any kind of community event, then I'd love to send 2 free print copies your way. And so just reach out and we'll have a dialogue. And I'd love to support the group and send out some free books of .NET DevOps for Azure. And so that was launched at the Microsoft Build Conference, and we're really excited about that. And the preview edition is out, but we're working our way up to a full release on Amazon.com and Barnes & Noble and things like that. So today's topic, it recognizes that so many teams out there hear about Netflix and Facebook and even the Azure DevOps product team doing middle-of-the-day deployments and wonder how to achieve that for themselves. And so this show is just about that. My guest today is Eric Fleming. Eric is a software architect at ClearMeasure and leads an intense team developing and operating a mission-critical software system in the financial sector. Eric lives in Alpharetta, Georgia, and is a host of the Function Junction YouTube channel, and it's really been growing in popularity. It's all about Azure functions. And he's also written articles for MSDN Magazine and Code Magazine, to name a few. You can find him on Twitter at @efleming18. That's EFLEMING18. So, Eric, welcome to the show. How are you, sir?
I'm good. Thank you for having me. It's a pleasure to be here.
Yes, sir. Absolutely. So, you have a really interesting story. I know all the listeners are going to love hearing about it. You basically inherited a software system that could not be deployed in the middle of the day, right?
That is right.
And now, after working on it and changing it, you finally achieved middle of the day deployments.
Yep.
So rewind, all the way back, and tell us that story. What were the characteristics of that software system when you couldn't deploy in the middle of the day?
Yeah, for sure. So when I kind of came onto the project and where we were at the time was we were about to go through some major changes, some major feature development, some really big initiatives that we were working towards, and we had a monolith project. We had this one big GitHub repository that had 10 handlers, a couple APIs, a couple database projects. We did have one other project that was kind of standalone. So that one was a little bit easier. But the main one where all of the core functionality was to run the entire system was in this one repo. And
you said 10 handlers. For those listeners, what the heck is a handler?
Oh yeah. So a handler. So when I refer to a handler, I'm talking about an end service bus handler. So end service bus, definitely check it out. We use it for all of our pub sub messaging. It's been a keystone for our project and other projects that I've had the chance to work on. It's insanely easy to get up and running with using, and it's the documentation out there is great. The team over at particular software that creates N-Service Bus is amazing to work with. If you ever have any questions, the service, the support is great there. It's a great experience. But yeah, so handlers for us are N-Service Bus handlers.
And how do they run? What are they?
So you can run them a couple different ways. You can run them in the cloud, but for us we run them on VMs. So they run as Windows services on a VM.
Okay, so you had 10 Windows services. And how many running processes were a part of the system?
Goodness. So we have, you have the Windows services, you have the scheduled jobs, you have the APIs running in IIS on the VM itself as well. One VM, by the way.
So over a dozen.
Oh, well over a dozen. Yeah. I mean, there is definitely well over a dozen. And like I mentioned, it was just one server as well. So this one monolith running on one server in production for a fairly large project, a fairly large, system that we had. And that's kind of, already right there, that's your single point of failure. If that VM goes down, at the time, Terraform wasn't really anything to be in the picture to quickly and easily spin up a new VM. I mean, the VMs lived for a very long time out there. I mean, they would get security updates and patches and everything like that. Right. But there was no easy, like if that VM went down somehow, it was going to take
a big risk.
Yeah, it's big risk.
So did you have any DevOps capabilities in the mix when you took over that leadership role?
Yeah, so I mean, we have, we were, CI. We were using Team City. Team City. Every PR, every branch was being built, creating releases. We were using Octopus Deploy, even back then.
Okay, so you had automated builds and automated deployments.
Right. But in order to deploy it to a single server, it would require downtime. Yeah. Because, the Windows service has to, you have to shut down the Windows service, uninstall it, deploy the new code out there, and, reinstall everything, so there's downtime, right? The queues are going to back up for N-Service Bus. The APIs are going to be down momentarily while it's starting back up. So doing it during the day or even without a maintenance page was impossible. There's going to be no way to do that.
And you've got just loads of transactions hammering this thing, from what I understand, every minute of the day.
Yeah, I mean, now, we're a couple years later, but we're hundreds of thousands, probably millions of messages being handled by all of the different services that we have, and that's just the N-Service Bus handlers. That's not even the API requests. API requests are probably, maybe not as high, but it's still, hundreds of thousands a day.
Right.
So if it's down for even, 10, 15 minutes, and that would have been on the quick side. It would have, to do because it's in a monolith, it's going to do everything, right? It's going to have to do everything all the time. So that's going to be a pretty long window of time.
So you took down the entire system in order to do, was it a Friday sometime window? When was it?
It was, maybe once a month. It was a lot of changes. It was usually a 2-hour window, 2-hour window, just in case, where we put a maintenance page up and then, deploy the code and hope everything went well. And if it did, hour later, we'd be done, hour and a half, 2 hours, whatever, we'd be done. And we could bring everything back up, but that's still, 2 hours, it's a long time, it's a long time. It's a long time of business to be down. And because we have to be down for so long, we have to do it when there's the least amount of traffic on the system. So primarily the project, the consumers of the end product there are all of, in North America, right? So 3 a.m. is when the least amount of traffic is.
The lightest load.
Right. So what does that mean for the developers and the people pushing the buttons to get the code out there? That means you're getting up at 3 a.m. and starting your deployment at 3 a.m. to minimize the amount of impact that you have for the customers.
Now, how many years ago was this roughly?
This was about 4 years ago.
Okay, so roughly 2015.
Yep.
So if the term DevOps was coined in 2010, around 2015, you're still very much an early adopter when it comes to automated deployments, just flat out. I think continuous automated builds, 2005 and 6, those are the early adopters. But by 2015, automated deployments were still pretty cutting edge.
Yep.
So you already had that, but still, because of other characteristics, you had to wait once a month to deploy,
Right.
and have this 4-week business cycle. So fast forward today, what does it look like today?
Today it's great. Today I couldn't tell you the last time I got up at 3 a.m. It's been 8-9 months now. We deploy whenever we want, usually just in the middle of the day. We have short. We still call them releases, but it's a very Kanban type flow that we have. So basically, whenever the feature's done and tested and ready to go, we have the green light to push it to production.
Mm-hmm.
There's no downtime. Right now, we're running on 4 app servers at all times. So we do a rolling deployment. So we can, the end service bus handlers and the APIs, they will shut down gracefully on, the first app server. While we have the other 3 servers there. I mean, we don't need all of that, but we have it there for redundancy and to be able to do rolling deployments and everything. And so it rolls out gracefully. We can do it with no downtime. Nobody notices any blips in traffic, and it can go out whenever we want it to.
Is there anything that you attribute to the ability to handle such a high throughput in only 4 app servers? There's other people I've spoken with that have several dozen servers. For what is it about the structure of this system that gives you that compact footprint?
So, for us now, we're in microservices. We have a bunch of microservices. So, or a bunch is in about 50 microservices now. And
okay,
each one of those, if we were still in the monolith and we were trying to do too much with too many with one handler, right? With one end service bus handler, so there are too many messages going through it, updating, not necessarily the correct database, the right schema, the right database. So now we have this structure where we're deploying much smaller pieces. So the impact or the amount of traffic going through one handler is not as great as it was before. So like now the queue will maybe get to 3 messages deep.
Okay, so does that mean you have 50 independent processes that are running on each of the 4 servers, or do you have them segmented?
Right. So so they're all running on each one of the 4 servers.
Okay, redundant.
Right. Yeah, very redundant. So if there is, for whatever reason, a VM or one of the VMs would go down,
Mm-hmm.
it would, it basically just shuts down, and we really don't even notice an issue there either, where we just like, okay, we realize that the server went down. We're going to investigate why that server went down, but we have 3 here still ready to go. And by the way, we can spin up another app server, no problem. Now, in these days, we can spin up a new server, no problem, deploy all the code out to it, and we're up and running with 4 app servers again, if we want them.
Okay, I want to come back to that because that's an important point. But when I've heard a lot of people talk about microservices and what they follow it on by saying service A calls an API of service B, which might call an API of service C, D, and F, and it's a lot of HTTP calls.
Mm-hmm.
But I hear you talking about queues.
Yeah. So
it seems like maybe it helps you out with that throughput.
Very much so. Yeah. Yeah. So there are very few these days. There are very few instances where we will call another API from another internal API from another service. Right. What we do now is we do a lot of message handling with the queues. So if we need to get data, or we need to update data from another service, it's a message, right? We're going to be able to put a message on the bus, go update it here, or and within service bus you have the ability to to do some request reply stuff as well. So it's an asynchronous process, but it will wait for it, so you can actually get the response of what just like the success response, and make sure that it actually succeeded.
And when you say wait in asynchronous, what's the average wait time for a message?
Milliseconds. I mean, it's
okay. So
it's not really waiting.
So it's asynchronous, but when the system is working normally, it kind of seems like it feels instantaneously. Would that be right?
Yeah, I mean, it's very instantaneous. I mean, with an HTTP request, you have overhead of just making the HTTP request of, some, non-zero number of milliseconds. With the messages, you don't have to do that. You don't have that overhead.
Right. Okay.
So you can even, in my experience, I've seen a lot of the messages actually process faster than if we were just doing HTTP requests for data.
Okay. So you deploy right in the middle of the day, but you have 50 processes that need to be deployed. So what's your decision process or your structure, and how often do those 50 get deployed?
So it's not it would be a very rare occurrence if we were actually deploying all 50. The only time we were ever deploying all 50 at one time is if we've spun up new servers and we need to get everything out there. Right now it's we have a microservice. We had a card, we had a feature. We updated one microservice or two microservices in order to complete the feature. So when that feature is ready to go, we have our release branch. It's ready to go, and then those two services are the only ones that we're rolling out to production at that time. Because there's no sense in rolling out a service that wasn't updated, because there's no changes, there's nothing to do with it, and we only need to roll the two. So we roll two of them out there, and
so most of your deployments, the target of the deployments, sounds like it's a Windows service at the moment.
Yes, yeah, most of them are Windows services. We have a couple of cloud, resources, functions type of Azure function type thing as well. That we can deploy to, or that we do deploy to, but most of what we do now is going to Windows VMs.
Okay. Do you also have zero downtime when you have to deploy your web application processes?
Oh yeah. Yep.
Okay.
Yep.
The Azure DevOps podcast is sponsored by ClearMeasure, a software engineering firm and Microsoft Gold partner, empowering development teams to be their best. ClearMeasure equips developers with the DevOps tools, methods, and automation necessary to focus on building their applications, rather than wrestling with builds, deployments, or environments. Click clear-measure.com to see whether a DevOps implementation is for you.
So I want to go back to this 50 services. Before you had one Git repository with a very large Visual Studio solution with some dozens of independent processes, but I guess it all got the same version number, so it all had to be deployed together.
Yeah. And
now you have 50 Git repositories?
So no. We have slightly fewer than that, because there are a couple services that have an API project and a handler project in there that they are in the same repo, and they will get deployed at the same time typically, but they are an individual deployment.
Okay.
Object.
So some of your microservices have more than one deployed processes.
Yes.
Okay. So are you in the 40-ish Git repositories?
Yeah, I think we're mid 30s, low 40s. I think is what we're at right now.
Okay. So if we get rid of all jargon, then we have somewhere between 30 and 40 applications.
Yes. Yeah.
We just use more generic terms, because everyone's trying to. What the heck is a microservice?
Yes.
I've never seen one out in the wild.
Yeah.
And it sounds like it's not a magic jargon. It's an application, and it's a piece of a software system.
Yes. Yep.
Okay.
Exactly.
Now. Okay, let's take one of your ones that is a Windows service, and it has its own Git repository. What does that structure look like, and what is the DevOps environment for one of them? What are the pieces that you have there? Right.
So obviously we start with the Git repo. Anytime we have a develop branch, it's basically what we call our master branch, essentially. So
So
whenever
you're using the Git flow pattern?
Yeah.
Okay.
Yes. And so right now, what happens is whenever a pull request is made and merged in to develop, we automatically kick off the builds. And it builds the project, builds the artifacts. Once it's successfully built, it runs our integration test, runs our unit tests, builds it up and pushes it to Octo. Then we get to Octopus deploy. Octopus deploy will automatically deploy to the integration environment that we have, run some smoke tests out there. Once that is successfully gone through, it goes out to the UAT environment. Once it's in the UAT environment, we actually pause there for our for the manual testing to occur. Mm-hmm. So people come in, they will manual test, and once it has passed there, then it actually moves on to the stage environment. And once it's into the stage environment, it's good. It runs through we run through the same amount of testing and everything. Once it's checked off in stage, it's whenever we're ready, we can push it to production.
Okay, just for that service.
Yes.
Just for the Visual Studio solution that's in that Git repository.
Yep.
Okay. And so nothing on any of the other services is happening when that's taking place?
It's just this one.
So if you just had to change that one, then that's all you had to mess with.
That's the only one. You have your big Octopus deploy dashboard, and that's the only project you see being deployed out. Nothing else is changing. Nothing else is going out. No versions are being updated for anything. It's just this one handler, this one Windows service being deployed out through the environments.
Okay. Now, when you mentioned that any developer can deploy whenever they want to. Mm-hmm. Going back to the previous process when you started, there was a big business event once a month.
Yes.
And so I'm guessing that lots of people in various parts of the company were very aware that it was happening and were involved and whatnot. Who's involved now whenever part of this system is being deployed?
Yeah. So like you said, in the past, it was an event. It was
once a month.
Right. It wasn't just, you couldn't just have one developer push the code out. It was going to be multiple developers who worked on certain features. So sometimes it was 3, 4, 5 people that were on that release just from your one team. And then you have the product owner that's monitoring it. You have, other teams if they were deploying as well. So it was, there were, 10 to 15 people sometimes on these releases just to make sure that they go smoothly. Mm-hmm. So now, like you said, it's, you have the product owner who has done the sign off and the testers, everyone's confirmed, sign offs have happened. There's been a change request, change approval process that's gone through. Someone said, yep, we're okay with this going out to production. And then it's just basically a Slack message in the channel that says, hey, you have the green light to push. And then one of the developer that worked on it or, whoever, if they're unavailable at that time, it's just, hey, can you, just deploy this to production and that's it.
And they're fine with it.
They're fine with it because there's so many, it's such a smaller piece now that is being deployed. It's such a smaller segment and exactly, when you have a month-long release, when you have this month-long cycle, there are so many changes going in. It's really hard to keep track of, if something's going wrong, it could be one of 15 things that went in that could be the issue. Now you're deploying 1 to 2, maybe 3 things per deployment. And now, if something happens, if you're, you're alerting we're using Sumo Logic, New Relic. If your alerts start firing right after a deployment, it's like, hey, I know where the issue is going to be because we just deployed this. You can either roll it back or you can roll forward.
Okay. So you have really good observability characteristics.
Absolutely. Yeah.
Sumo Logic and New Relic, they're both in the APM space. So I guess you've centralized all of your logs and you can query them anytime?
Absolutely. Yeah. That is, getting to this point, just being able to show and prove that you can detect a problem that's happening and detect it quickly with, we're talking minutes, to be able to detect that something is going wrong is a huge thing because it gives you as the developers the insight that you need to have confidence that what you just pushed out didn't break anything. And it gives the business the confidence that, hey, like, we know that if something goes wrong, we're going to know very quickly, rather than 3 days from now when, oh my goodness, we've had this production defect and it's a big deal. We're going to know immediately. And that's sure, you can have all the, you have great processes getting everything out there, but if you don't have insight into what you just did or what is happening in your system, it's a very slippery slope there. And that's, in my opinion, a very, very important piece of having that insight. Okay.
Now you mentioned Kanban, but go back to the monolith and monthly deployments. Was there development process differences, or were you using Kanban or a flavor of that then as well?
No. It was, so it was still Agile. I don't even know.
Extreme programming, Scrum.
I think that we wanted to call it Scrum. There were multiple product owners. There was multiple things happening on one board.
But you attempted to run sprints.
We attempted to run sprints.
Monthly sprints?
Yeah, we went from monthly, and we got a little bit better. We went to 2 weeks, but for a while it was monthly.
Okay. And so at the end of the sprint, you had shippable software, and you did ship it, and you had the monthly releases. Okay. So now you're shipping every day or whenever you need to?
Yeah.
Okay, so what has become of the sprints when you have that type of process where you're deploying anything whenever you need to?
Yeah, so that's interesting. Of how we're doing it now is basically, we don't really, we have meetings, full team stand-ups, twice a week, when we're interfacing with the product owners and everything. But really we go with the highest priority items. Like, the highest priority items for the business are what get worked on. And if that's something we can get done in a day, then we get it done, and then the next day or the next day or two, or whenever it's finished.
Wait a minute. Hold the phone.
Okay.
You said that there are some features that you can get done in a day.
Oh yeah.
All right. For most of our listeners, that just doesn't happen.
Oh, that's, yeah.
Talk a little bit. What kind of features are we talking here? Are we talking about changing the background color on a screen? What are we talking about here?
No, we're talking about implementing logic, really, that will drive new business features. And the way, just thought about this. This is an important piece. So one of the ways that we can get a lot of these features in, a lot of these big features that are really will add value to the business, are feature flags. And being
able, y'all use feature flags.
We do use feature flags.
Okay.
So we can get a feature in, if we need to interface with another team, and they may not necessarily be ready yet, but we just put it behind a feature flag. We just have it, toggled off for right now. And the logic still goes into production and it's ready to go. We can test it in UAT manually. Mm-hmm. And then when it can go to production, and it's just sitting there ready in production until the next team, that we have to integrate with is ready to go. And then it's just, it's just flipping a toggle.
Okay. So you implement it in the space of a day, you deploy it out there, but turned off.
Right.
So, okay. What does this look like? Are you using a feature flag library or tool, or did you just implement the pattern yourself?
Yeah, so right now we've actually implemented the pattern ourselves, and it took maybe a week or so to get it up and running. So it's just a very simple. We just built a simple UI that is just feature flag name and then an enabled or not checkbox, and we just we have a actually. Because we're in microservices, so we want to be able to share that, the common code in order to be able to read those toggles. Mm-hmm. So we have another package, a NuGet package that holds our code that knows how to talk to the back end of where these toggles values are stored. Mm-hmm. And then we inject that into, or we pull that package into our projects. And then via NuGet.
Okay, so one of your services owns a library that you need to share.
Yes.
And in the build process, you're packaging up as a NuGet package,
Yep.
sticking it in your feed,
Yep.
and then just including it like anybody else would include a library.
Yes, exactly.
Gotcha.
And
Okay.
then yeah, I mean, so there's the logic that you put in the startup to wire it up, obviously, and then it's just calling it, normally in code, it's just our toggle management service, and then you
Okay, so every one of the other services then must have to be deployed with some type of config setting
yes, there
that the feature flag library needs?
correct. Yeah, so there's config. So right now we have it just backed in SQL right now, and so we have a common connection string that is shared. It's a shared variable across all of our deployments.
Okay.
That knows that knows that specific value.
That's an interesting scenario. That's an interesting microservice scenario that I don't hear getting talked about a lot, and that is the in-process microservice.
Right.
Where it's a microservice that doesn't get deployed on its own. It gets deployed as a library, and it runs inside the
Yeah.
consumer's process.
Yep.
So that, guess what? The consuming application, like you said, it's calling out to a database
Yep.
that microservice owns, and it's happening in the memory space of the consuming application, but the consuming application has no idea that database exists.
Yep. Yeah. So and you can so because of that, because of how it works, we can change that from SQL if we want. We can put it into something in Azure, something like that. If we don't want to put it into our SQL Server instance and everything, we can store it wherever we want, and the consuming application doesn't care, right? It just it's taking this connection string that we just update the values, and it just knows how to do it. You just update the NuGet package.
So back to sprints. I'm not hearing that sprints even exist in this new world.
No.
Or are they one-day sprints?
Yeah, I mean,
and become meaningless.
Yeah, I mean, you could consider it a 1-day sprint because or 1 day. I mean, you could probably consider it a 3-day sprint if it's a really large feature.
So really large features take 3 days now.
Yeah, those are the ones. They're a pain. They take 3 days, and no, it's yeah. I mean, we try to move very quickly. It's because we're in microservices and just the idea of breaking things into smaller pieces. Even if it's a large feature of what it seems like, you can break it down into many smaller pieces, right? So you can work on, a task of a bigger feature and have it toggled off, and then keep developing it as you go based on how the requirements come in, based on the other team's integration and where you're going. If you have all the requirements yet, you can really break things down, make them smaller, get them out to being able to be tested into production as quickly and as often as possible. And then by the time the whole feature is done, you have all of the smaller pieces done, right? You have them all tested and ready to go. So by the time you turn it on, the full way, each piece should be tested, and you're going to know if there is a hiccup in production, which everything should have been tested, thoroughly through the lower environments. You should know where the breakdown's going to be.
Okay. So we kind of fast forwarded from very big Visual Studio solution, all version deployed together, to now you have 30 some odd Git repositories, 30 some odd pipelines and whatnot. But we didn't talk about how to get there.
Yeah.
So if I'm listening to this thing and thinking, okay, how long did this take? What were the major transformations that you had to execute to arrive at where you are, which sounds like pretty drama-free day to day?
Yeah, it's I mean, it definitely takes time. I mean, that's the thing. You're not
Well, we're talking about 4 years, I guess, over this progression?
Probably more about 3. I mean,
3 years?
we've been in a pretty good place for probably about 3. Probably about a year and
Okay.
about a year we've been in the position where we can, kind of deploy.
So how
whenever.
did you start breaking up your monolith? What was first?
So first, I mean, because we had all the handlers and we had the APIs, we already had a little bit of an idea of separation of what we could do. So we looked at some of the handlers and it's like, okay, this handler is doing way too much. Mm-hmm. And so maybe this handler was trying to generate a document, and this handler was just trying to upload something to Azure Blob Storage or something like that. But maybe they're two very distinct processes, right? Like they don't care about each other. They don't even pull data from the same spot in the database, right? So there it kind of seems like maybe there's a logical split we can make. That's a new service. In some of the bigger initiatives that we were talking about, it was we want to take a lot of what we're doing and we want to break it into two distinct sections of the application, right? We want to make a break here. Like we want to be able to build up this set of data, leave it in its own database, and then convert, we send a command to the other service in order to kind of like start something new from all the data we've collected in that beginning. So that's another service, right?
Okay, so it sounds like you started with the low-hanging fruit and figured, okay, what could live on its own? What could have its own life cycle?
Definitely started with the low-hanging fruit and kind of built from there.
Okay.
And it was, like you said, kind of the last things that get pulled out are kind of the bigger things that may seem like they're really intertwined, but then when you start unraveling them, it's like, oh yeah, this definitely could live by itself.
Yeah. Now, even with the monolith, you had an automated build, and you had a big automated deployment, and you had some automated tests?
Yeah. Yes. So automated tests, we had, so unit tests, of course, integration tests, of course, but then we did try to start building up some UI acceptance tests.
Full system tests.
Full system tests, yeah.
Okay, so you had 3 different tiers of test suites. Would you have been able to start breaking this apart if you didn't have automated tests, do you think?
No, absolutely not. Just because there were so many pieces that seemed like they were intertwined, and pulling them out, being able to like pull out, this chunk. Right, so just even at the unit test and integration test level, I want to pull out this chunk, right? So I'm going to take this chunk, I'm going to put it in a new service, I'm going to pull over all of the unit tests that go with it, and in doing that, you see like, oh shoot, like I need this piece still. This piece needs to be moved over, or this piece actually can't move over because it has to talk to this, this database table that should live with this microservice.
Gotcha.
So there's, without being able to do those tests, and then being able to do the automated, full system tests of calling the APIs to insert data or get data, and then to trigger other messages and everything like that. Without those, or at least having an idea of how to build those and how to run through the full system, it would be impossible. You're never going to catch all the bugs. There's always going to be, probably something you're going to miss, but that's why you write more tests, right? You get that complete code coverage up front so that you have the confidence that, oh, hey, this service looks pretty good now. I have pretty good confidence that when I push this out to the UAT environment, it's going to work, right? Okay. So, yeah. So without those types of tests, it's
awesome,
near impossible.
So it sounds like a developer's dream to work with the system as it is now, and it sounds like a lot of work to get there.
Yes.
Were there any resources or books or learning material that were helpful or would be helpful to listeners if they might be in the same situation? What could we point them to learn more? Yeah,
so I would for sure, some things that helped me out in the beginning were a book, Accelerate. Really helped me out. It really puts in perspective, what it means to get it in, what it means to have a solid deployment cycle, and to be able to deploy in the middle of the day, and just for what it does for team morale. Another one would be the DevOps Handbook. That one, I remember we did that with actually going through it as a team to go through and make sure we have we have an understanding. We all agree with, yes, this is what we mean. This is what we should do as a team. The DevOps Handbook, I would definitely recommend.
Okay, it seems like both those books are from the same author group. You got Jez Humble, Gene Kim, Nicole Forsgren.
Phoenix Project too, which I think some of them are also on.
Yep,
on that.
Definitely similar author group.
Yeah, yes, Phoenix Project. That was that's a big one to just the Phoenix Project really. Without trying to give too much away, for people who would like to read it, highly recommend it. It really shows that like it's not going to be a fast overnight process to get to be able to do something like this, but it will be worth it in the end. 100%. There is no question about it. Take the time. Build the team around you that will want to get to that same end goal. And just the team will be happier. Your product will be much quality-wise, it just goes through the roof. You can deploy it whenever you want. Definitely Phoenix Project will show you that. Also the .NET book, your book here. I wish I would have had it about 4 years ago, because that just the concepts in there and the kind of the guidelines and the rules that you talk about in there really help kind of put a lot of this stuff in perspective. And having this 4 years ago would have been great to kind of start guiding us into how we get to some of these places, because like a lot of what I've described is a lot of the rules of how to get there that you describe in the book. So, well,
I hope it helps.
Yeah.
Well, this is such a compelling story that you've laid out in, I guess, the 3 years, which tons of work, but I think everybody wants no drama, uneventful deployments, and be able to deploy whenever they need to, as opposed to waiting for specific times. So, man, I appreciate you sharing it with me, and I know it'll be a really compelling story for all the listeners and giving everybody hope. It's like, it's being done. It's reachable. It's attainable.
You can do it. Yes.
Awesome. Hey, well, thanks, Eric, for being with me today.
Yes, thank you. Thank you for having me.
And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.